Morning, Nana. Deepti. Today, today we will learn another topic. Yesterday, Becker's method completed. On that problems also we have completed. Today, go to the next concept of means model type questions. Groups heading. So groups of subheading, that is groups of unequal sizes. Unequal sizes. Equal sizes and another unequal sizes will be there. Okay. So let us first starting with one example, then go to the formula. Example. Number of ways of dividing 10 people into groups of 6 and 4. So number of ways of dividing 10 people into groups of 6 and 4. So write down one example. Let us take one example. Number of ways of dividing 10 people into groups of 6 and 4. So that is number of ways of dividing two groups are we have completed. That is 10 people are there overall. Then it can be divided into two groups as size, unequal size. That is one of the size of a group is 6 members. Another size of a group of a people is 4 members. So take a rough diagram, that is 10 people are there. One group is divided into 6 groups, another group into 4 groups. Okay. How many arrangements can be done in number of ways of dividing this condition? So out of 10 people, we are selecting a one group that can be done in 10 C6 ways. First group unequal size. And then go to the next. How many remaining people? Remaining nothing but 10 minus 6, that is 4 people. 4 people can be again selecting from another unequal group, that is 4. This can be done in 4C4 ways. Okay. So out of 10 students, we are selecting into 6 people. That can be done in number of ways is 10C6. And then for remaining 10 people, out of 10 6 people are we are selected, remaining people are 4, and then go to the next group, that is 4 people are there. So then it is can be done in 4C4 ways. So this total value nothing but NCR formula. NCR equal to n factorial by n minus r factorial into r factorial. This is the formula. Now substitute here 10 factorial by 10 minus 6 factorial, that is 4 factorial into 6 factorial into 4C for nothing but NCN. NCN equal to how much? 1 way. Therefore, the number of ways of dividing 10 people into groups of 6 and 4 is 10 factorial by 4 factorial into 6 factorial. This can be written as 6 factorial into 4 factorial. This is the number of ways of dividing 10 people into two groups with unequal sizes that is 6 and 4. So in shortcutly we can write as this figure we can draw, then write it as directly, by how many values, how many group of people is there directly we can write from the figure, that is 10 factorial divided by the group size is 6 factorial and another group size is 4 factorial. That is the final answer. Indirectly we can write. Okay. If it is not getting means out of 10 people we are selecting 6 people, make a one group, we are selecting the first group of size, then it can be done in 10C6 and then remaining people are 4 members are left over. Out of 4 people we can done in 4C4 ways, so that is 10C6 can be written as this. Okay, and directly we can write as some shortcutly we can write as 10 factorial by group of size 6 people are there and then remaining 4 people, so 6 people size can be done in 6 factorial, size of 4 people can be done in 4 factorial. Let us take the second example, example 2. The number of ways of dividing 10 people into group of sizes, number of ways of dividing 10 people into groups of 5, 3 and 2. In before that problem, the problem is number of ways of dividing 10 people into two groups of 6 and 4. Here we are doing the number of people 10 people into groups of 5, 3, 2. Rough diagram we can write. So of course first group of size is 10 people, second group of size is 3 people and third people size is 2 people. So first we are selecting from this, selecting out of 10 people first group. This is the first group. So this can be done in 10C5. Okay, out of 10 people we are selecting first 5 people. This can be done in 10C5 and then next remaining how much? 10 minus 5. 10 minus 5 means 5 people remaining. 5 people can be done into the second group we are selecting. This can be done in 5C3 ways into next remaining people 10. 8 people are completed. 8 people means remaining 2 people will be there. So this can be done in 2C2 ways. Then this can be simplified as by NCR formula, that is n factorial by n minus r factorial into r factorial and then 5 factorial divided by n minus r factorial means 2 factorial into 3 factorial, 2C2 nothing but 1. Then simplification, then you get the value as 10 factorial by 5 factorial into 3 factorial into 2 factorial. This is the number of ways of dividing the 10 people into groups as size of group is 5, 3, 2. In shortcutly we can write shortcut. Then shortcutly we can write by observing this expansion. So total number of ways is total number of people are 10 and the group size equally we can write 5 people are there, so 5 factorial. Group of size 3 is there, 3 factorial and another group is 2 factorial. Then only directly we can write the answer. This is also directly from the group of people, 10 people, out of 10 people, groups can be divided into like this. Or else solve like this. But in the drawing a figure like this rough diagram, we can write as directly. Okay. From these two examples, we can generalize that the formula. The formula is, you can write as a formula. First formula you can write. Number of ways of dividing total M plus n people are there. M plus n distinct object into two groups of sizes M and n. Then we can write the formula is number of ways of M plus n distinct objects into two groups of sizes m and n is, what is the formula? Total things are m plus n. Then the group of sizes are different. That is 5. M is size of a one group and another group size is a n. So this can be divided into two groups as m group and then n group. Directly we can write as the total value denominator, that is m plus n factorial by m factorial into n factorial. This is the formula. So number of ways of m plus n objects into two groups of sizes, then it is can be divided into two groups. The formula is m plus n factorial by m factorial into n factorial. Okay, Shruti, are you understood, Nana? Deepti, please inform to your friends. Shruti, Deepti, Pranasagar is there, Lohit is there, Chetan is there. Okay, similarly, second formula, from this rough diagram, we can say that directly m plus n factorial by m factorial into n factorial. In the similarly, the number of ways of dividing m plus n plus p distinct objects into three groups of sizes. Let it be m of s group size and n, and then next group size is p. What is the formula, Nana? What is the answer? Give the response. The number of ways of dividing total things are m plus n plus p of distinct objects into three groups. Let it be m is a group of one size and another group size is n, and then p is the another group of size is p. Then formula we can write as, how will you write? Directly m plus n plus p is total things. Then can be divided into m group and n group and another group is p. Then the formula can be written as, what is Nana? M plus n plus p whole factorial, number of total things divided by separate groups of sizes. So that's all. This is the formula for, and if the number of ways of dividing three groups out of m plus n plus p things, then the group of sizes are to be m, n and p. Then the group of sizes, then the formula is total answer divided by group of sizes. M factorial into n factorial into p factorial. Okay, are you understood and give a response? These are the basic formulas. On this process, we can some problems we will do. Okay. Who is there in the group? 15 members are there now. Give the names. Who are there? Okay, same thing. Next concept. If it is formula for groups of making into unequal groups. Now we are going to learn the values if it is groups of equal sizes are there. Okay, Sindhuda Siddhartha. Okay, fine. Just now added. Don't miss the classes, Nana. All are examples and concepts of objectives. So, next, go to the next form of groups of equal sizes. First topic is groups of unequal sizes. Now we are learning the groups of equal sizes. Let us first take the example, then after we will go to the formula. how to derive the formula. The number of ways of dividing 4 people into groups of, let it be 2 and 2 equal groups are there. So then the formula becomes to write the number first. The question is number of ways of dividing 4 people into groups of 2 and 2. In previous problem, we can find over that number of ways of dividing 4 people into unequal sizes as 3 and 2, let it be 5, 3, 2. But the groups of equal sizes, then how many is dash? So total things are, present people are 4. Then we can divide it into 2 group of people. So let it be one group size is 2, another group size is 2. But as per previous concept, we can write as directly by 4 factorial by 4 factorial into 2 factorial. But it is not a correct. It is same group of people are there. Then let it be A, B, C, D people are there. So join with one of the group as AB and another group let it be CD. Or else like this in the form number of another way is let it be AB and CD, and how many ways are there? 2 ways. 2 ways nothing but we can write as 2 5. Therefore this is wrong, but total number of ways equal to we can write as 4 factorial by extra additional 2 factorial into 2 factorial into 2 factorial. Why? Because 2 factorial we can write extra, that is a group of sizes. Number of ways can be arranged in among themselves, that is ABCD is a one group, one way, and CD and AB is one way. So that it be, then we can write here 2 factorial. This value is correct only. Up to this, it is not correct, but the group of size is equal size. Then divide with 2 factorial. Then it will be correct. Why? Because the number of ways becomes 2, A, B, C, D, or else C, D and A, B. So that must and should you have to write group of number of ways, that is 2 factorial once again. So the answer is 4 factorial by 2 factorial into 2 factorial into 2 factorial. Similarly, let us take the second example. The number of ways of dividing 6 people into groups of 2, 2 and 2. So same thing, but the group of size is equal and the number of groups as 2, 2, 2, 2. Three groups are there. By taking the rough sketch diagram, first group of size is 2, another group size is 2, and then I is 2. Indirectly we can write as 6 factorial by 2 factorial into 2 factorial into 2 factorial. This is not a correct way. Then go to the next, how much way? How many groups are there? It will becomes 2. Correct way nothing but 6 factorial by 2 factorial into 2 factorial into 2 factorial, and then divide with how many groups are there? How many groups are there? 1, 2, 3 groups are there. So 3 groups nothing but here we can multiply with 3 factorial, then it get going to the correct answer. How many number of groups are there? So just we can divide with the number by 3 factorial. How will you get means? Let it be A, B, C, D, E, F are there. So making to two equal groups, that is AB is one group and then CD is one group and then also EF is a one group. Similarly, next group value is AB and EF and CD, another group. Next CD, another group is CD, then AB and EF. Next, another group will form as formation is CD, EF, and AB. And another group formation is EF, AB, and CD. Next, another group is like that AP, EF, CD, and AB. How many arrangements are totally? 1, 2, 3, 4, 5, 6. 6 can be written as 3 into 2 into 1. Then it is goes to 3 factorial. If 2 people size of is there, then you get 2 factorial, ways 2 into 1. Then here, number of people are 6 people are there, we can write as a 3 factor. So that is why we can divide the factorial as 3 factorial to the group of people, dividing into 6 people as a group of 2, 2 and 2. Then the value becomes to correct answer. Then only it is correct. Afterwards, before that this factorial, this is ungroupable size, but equal group size we can divide with the 3 factorial. Why? Because this is the number of ways of dividing 6 people. Okay. Now we can generalize the formula. Let us take one more example. So, 12 people are there. Directly I am writing. 12 people are there. The group of size is 3 people and another group of size 3 and the next group of size is 2 and then another group size is 2, then another group size is 2. How many number of ways can divide it into 12 people into groups of 3, 3, 2, 2, 2, 2. Okay. What is the formula? Number of ways we are writing. Number of ways, how will you get? The shortcut method, total overall by 12 factorial. And then group of sizes, 3 factorial into 3 factorial into 2 factorial into 2 factorial into 2 factorial. But it is not correct. Then we can multiply, divide with the, how many groups are there? This is the first group and this is the another group. So then we can multiply with 2 factorial into 3 factorial. Then it will becomes correct. Okay. This is first group 3 3 and the another group is triple 2. Two groups are there. So by these two groups nothing but 2 factorial ways and 3 groups nothing but we can just know we have learned 3 factorial. Like this we have to write. Then only it will be correct. Okay. Understood? One question in the MSET level they will give the what is the next concept is you have to observe. Understood, Nana? Give a response. What is the concept is there? Shenmukha for Pranav Sagar, Lohit, Lohit, Chetan, Akhilesh, they were not present. Okay, next generalized as a formula for this concept. So formula is, first formula for this concept, number of ways of dividing two n distinct objects into groups of size n each is 2n factorial by n factorial into n factorial into 2 factorial. Rohit, give inform to your friends, Nana. Chetan is there. Chetan is not present. Anirudh, Chetan, Shanmuka, Akhilesh, Pranav Sagar, Anirudh. So number of ways of dividing two n objects. Okay, number of ways of dividing two n objects into groups of size n each of each is 2n factorial overall total divided by n factorial into n into what we have to write here 2 factorial. That is to write fast. Then the formula is like this. Next, second formula, if the number of ways of dividing, suppose 3n objects, 3n objects into groups of here two groups, here we can write three groups of size n such that 3n factorial divided by n factorial, three group of sizes divided into three group, that is n factorial into 3 factorial. So total answer divide with 3 factorial, then only it will be correct. These are the most important concepts. Don't get confused. So then only you can give the correct solutions for these problems. Okay. So observe first, whatever the values of the conditions are given, both are two expansions, most important formulas. Okay, if the number of sizes are two groups of equal sizes, let it be multiply with 2 factorial with dividing the denominator. If the group of size 3 and objects are there, then just you have to divide with 3 factorial. Okay. That is 2n means here nn, and that is can be divided into two groups. That is why 2n into 2n factorial by n factorial into n factorial. Two groups are there. Then write 2n factorial 1 by 2 factorial. If the group of size three groups are there, so 3n and n and n and n. Then divide with the 3 factorial, then only it correct. Here 2 factorial, then only it correct. If it is size of n each. Okay. Now on this basis, we can write some problems on this base. Okay, write down the question. Means problem question number 1. The set S equal to 1, 2, 3, so on up to 12 is to be partitioned into three sets A, comma B, comma C of equal size. Thus, A union B union C equal to S and A intersection B equal to B intersection C equal to C intersection C equal to null set, then the number of ways to the partition S is dash. To the partition S is dash. So what is the answer? You can try yourself now and give the response. What is the answer, Rana? Give the response. Okay. S is equal to whatever the value is given, 1, 2, 3, 4, 5, 6 up to 12. And then A comma B comma C are equal sizes such that A union B union C equal to S. Then and condition is given A intersection B, B intersection C, C intersection A equal to null set. Then we have to distribute 12 persons, 12 things into 3 sets as ABC. Therefore, the required arrangement is total things are S equal to whatever the values we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Group of total things are S equal to 12 things are there. And ABC are equal sizes. Equal sizes are there. And the condition is all the elements has to A intersection B and B intersection C. Obviously it is null set. Okay. Then we have to distribute. Then we have to distribute 12 things. Total things are 12 things equally to the 3 sets A comma B comma C. Therefore, total number of ways. How much, Nana? Give the response. How many are we will get? Total things are 12. In these 12 things, equally distribute the 3 sets as. Okay. Totally we can get the values equal sizes 12 things equal sizes, that is 4 4 and then 4. Just now we have learned the group of sizes are equal sizes, then we can divide with into how many groups are there, we can divide into the total values. Okay, if the expansions are 2n objects are there, 2n objects are there, 2n factorial by 2n n factorial into n factorial into 2 factorial. How many groups are there? We can divide with them into, so how many I will get? 12 factorial by 12 factorial by 4 factorial into 4 factorial into 4 factorial into how many groups are there? 3 factorial. 3 groups are equal sizes, so it can be distributed like this. So into 3 factorial we can write. That's all. This is the question. And then go to next question. Question number 2. The number of ways of dividing. The number of ways of dividing 100 cards into 2 groups of 60 and 40 cards respectively is dash. Options are given 100 C40, second option 60 C40, third option 100 P40, and then D option 60 P40. It is obviously this is a selection of things. Moreover, the values should not be in the form of arrangement of things. C and D will be get cancelled, and then answer will be in those only. What is the answer? Give the response, Nana. Pranav Sagar, Pranav, Deepti, Mallika, Sindura, Siddhartha, Rohit, Shruti. What is the answer? Question number 3, I'll write once again. What is the answer? Give the response. The number of ways. No. No. Second option. We are selecting total cards are how many are there? 100 are there. 100 we are selecting 60 and 40. So then the number of ways directly first formula. First formula we can write. First option Nishant, yes. First option from this 100 factorial divided by 60 factorial into 5 factorial. 100 factorial by 60 factorial into 5 factorial. Then we get first option. This is nothing but 100C40. It is in the form of n factorial by n minus r factorial into r factorial. Then it is goes to the first option only. Okay, third question. The number of ways of dividing 50 books into two groups of 25 each is dash. Options are given 50C25, 50P25, 1 by 2 into 50C25 and then 1 by 2 into 50P25. What are the correct answers? Give the response. What is the correct answer? Give the response. What is the correct option, Nana? Aishwarya, Nirali, Amulya, today absent. Yes, Vivek Gaud. Who is Vivek Gaud? Okay, option C is only correct. Why? Because 50 books 50 books can be distributed or divided into two groups of equal, that is 25 into 25. Group of size is equal, divide with it with its 2 factorial. Then 50 factorial by 25 factorial into 25 factorial into 2 factorial. So two groups of equal size, then you can multiply, divide with 2 factorial, which is equal to 50 factorial by 25 factorial into 20 factorial, nothing but NCR, n factorial by n minus r factorial into r factorial. 50 factorial by 50 minus 25 factorial into 25 into group of size equal group multiply. That is 50C25. 2 factorial means 1 by 2 into 50C25. The option C is correct only. Okay. Then go to the next question. Question number 4. So many problems are in the last 274 problems are there from the last pages. Listen backwards. So solve this one. Find the number of ways. Find the number of ways in which 12 things can be first bit divided into 4 equal groups, and then second one is distributed to 4 persons equally. So this is the question is given. 12 things are there. This can be divided into 4 equal groups. And second one is distributed into 4 groups, equal groups. What is the difference between among those two questions? Give the response, Nana. What is the answer? Write down in the chat box. What is the first question answer? Second bit answer. Write down. Nobody giving answer. What happened? Okay, first one answer is 12 things can be divided into 4 equal groups. So that should be 3 factor 3 way 3 3 3 3 equal groups, nothing but 4 equal groups. So this can be done in 12 factorial by 3 factorial into 3 factorial into 3 factorial into group of equal size, nothing but how many groups are there? Totally 4 groups are there. So divide with its group size, number of group size, that is 4 factorial. Then it is correct. Okay, this is for the first one. And the second one, the group of people can be divided into equal groups. Equal groups. Then it is goes to 4 groups, nothing but 4 factorial by 4 persons equally. So that is equal, nothing but 12 persons. 3, 3, 3, 4 persons equally. Twelve persons can be distributed into 4 persons. 4 persons as equally, that is 3, 3, 3, 4 persons equally. Then it is 3 factorial whole to the 3 factorial into 3 factorial into 3 factorial into 3 factorial. So that is goes to 12 factorial by 3 factorial whole to the power of 4, only 4. Okay. Then go to the next concept, that is divisors. That is divisors. So formula is any divisor can be any number, any natural number can always expressed as the product of prime numbers. Then we can find out the divisors by total how many divisors can come by using the some formulas are there. First divisors means number of divisors you have to find. So that is why first write down any natural number Any natural number n, natural number is n, can always expressed as the product of prime numbers. So that means therefore that is the value is, if it is n is a natural number, then we can write p1 to the power of alpha 1, p2 to the power of alpha 2, p3 to the power of alpha 3, so on up to pr to the power of alpha. So where P1, P1, P2, P3 are said to be prime numbers, P1, P2, P3, so on up to are prime numbers. And then whereas alpha 1, alpha 2, alpha 3, nothing but how many times it is repeated. That is P1 is repeated as P1 is repeated times. P1 is repeated as how many times? Alpha 1 times. And then P2 is repeated as alpha 2 times. Like this, okay? If any number can be represented as expressed as a product of prime numbers, if any number is there, so write in the form of prime number forms, then P1 to the power of alpha 1 means it can be divided, it can be repeated as times of P alpha 1 times, and let it be second number P2 is there, P2 is repeated as alpha 2 times, and then P3 is repeated as alpha 3 times, like that. Okay, let us take the values for the formulas for first number of how many in total number of combinations of divisors is. So total formulas I will write, then afterwards we will do the some problems. The total combinations of divisors, that is number of divisors, that means is how many we can get, means alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1, so on up to alpha r plus 1. Repeated times by or power to the power of plus 1 you can add and multiply. And then second formula is if P1 is odd, suppose if P1 is odd, then the number of odd divisors, then the number of odd divisors is alpha 2 plus 1. You can start with alpha 2 plus 1. Alpha 1 you don't take. Alpha 3 plus 1 and then alpha 4 plus 1. Then so on up to alpha r plus 1. So next third formula, if P1 is a even, then even divisors are, that means number of even divisors, that is alpha 1 into alpha 2 plus 1 into alpha 3 plus 1 into so on up to alpha r plus 1. Alpha 1 you can multiply. And then last formula, the sum of the divisors, the sum of the divisors, the sum of the divisors means total value we can add. What are the divisors we have to get? That is we can add, let it be divisors means P1 and P2 and P3 and so on up to PR to the power of P1. So this is the divisors. So then it has to be sum. Sum means P1 to the how many times it is repeated we don't know. So divisors. let it be P1 is divided into 1 time, P1 P2 P1 squared and P2 cube, let it be so on P1 to the power of alpha 1, then we can write as 1 plus P1 squared. So P cube plus so on up to P1 to the power of alpha 1. This can be using the formula, the basic formula it is in the form of Gp, that is A into R power n minus 1 divided by R minus 1. So for the series we can get P1 into the first term, 1 is same first term, then P1 to the power of n nothing but P1 to the power of alpha 1 plus 1 divided by P1 minus 1 for the first term. Similarly, second term value we can write P1 to the power of alpha 1 plus 1 minus 1 by P1 minus 1, and then next P2 to the power of alpha 1 plus 1 minus 1 by P2 minus 1, and then next P3 to the power of alpha 1 plus 1 minus 1 by P3 minus 1, and then so on, that is Pn to the power of alpha plus 1 minus 1 by Pn minus 1. This is the formula for sum of the all divisors. This is sum of all divisors. So on the basis of these expansions, first write down the examples, whatever the questions are in the examinations. First question, find the number of divisors of 1800. Suppose the number be 1800. Let us take the value 1800 plus make the prime factoration, that is you can take only by 2, 3, 5, 7 only you can take. Okay, 2, 3, 5, 7 like this. So 2 9 are 18 and 3 table 300 and 300 and 5 will take 520, 5 4 2 2s, 2 1. So this can be written as 2 cube into 1 2 3 and then 3 square into 5 square. So number of divisors means let it be in the form of P1 to the power of alpha 1, P2 to the power of alpha 2, P3 to the power of alpha 3. Therefore, we want number of divisors equal to alpha 1 plus 1, alpha 2 plus 1 and alpha 3 plus 1. Whereas alpha 1 here how much? Alpha 1 is 3. This is alpha 2 and this is alpha 3. Now multiply 3 plus 1 into 2 plus 1 into 2 plus 1. So that is 4 into 3 into 3. Totally we can get the value as number of factors of 36 factors will come for the number 1800. Just doing in the childhood level problems these are. 1800, that is making to prime factoration always in the P1 P2 P3 let it be PR up to all are prime factoration method. That is why then go to write as P1 to the power of alpha 1 plus 1 alpha 2 plus 1 alpha 3 plus 1 product. Okay, same thing the value goes to the second example. Find the odd divisors of 216 is dash. Find the odd divisors of 216 is dash. Odd divisors of 216. Just now we have learned odd divisors means take the starting from alpha 2 plus 1, alpha 3 plus 1, so on up to all values. Don't take the alpha 1. So whatever the values we get, don't take the alpha 1. What are the factors for 216? We can get 2 cube into 3 cube. to 8 into 27. 8 into 27, that is nothing but 2 cube into 3 cube. So then we can write alpha 1 equal to 3 and alpha 2 equal to 3. So don't take the first value of odd divisors. Then only the value for, take the value for alpha 2. The formula is number of divisors of odd divisor. The formula is starting with alpha 2 plus 1. So alpha 2, whatever the value we have now, so 3 is there. So total odd divisors formula is alpha 2 plus 1 and then alpha 3 plus 1, so on up to like this. But we have only alpha 2 here, then total terms becomes 2, 4 odd terms will come. That's all. That is the question number 2. And then go to the question number 3. The number of positive divisors, the number of positive divisors of 2,83,500 excluding unity and itself is dash. Give the response, Anna. Understood or Nishant, Nishita, Rohit, Deepti, Shruti. Are you getting this? Give the response. Okay, whatever the number, bigger number is given 2,83,500. This is 2 years back question. This is 2,83,500 can be written as our prime factoration. Then you get the value is 2 square into, I have done 3 power 4 into 5 cube into 7 power 1. Okay, this by doing the prime factoration 283,500 like this. Take the two values, so on up to the value, we can get the value as 2 square into 3 power 4 into 5 power cube into 7 power 1. So the number of positive divisors they are asking. So let it be the positive divisors first. You have to take the divisors. How many dividers you can get? This is alpha 1, alpha 2, alpha 3, alpha 4. Then the formula is alpha 1 plus 1, alpha 2 plus 1, alpha 3 plus 1 and then alpha 4 plus 1. Then the value becomes 2. 3 into 5 into 4 into 2. Totally we can get 23 just 6, so 120. Out of 120, the question is given that unity and itself, excluding unity and itself. Therefore, excluding unity and itself, equal to 120 minus same number means 1, unity means 2, that is 118. Total number of divisors excluding unity and itself are, unity means 1, itself number is itself, so then you get 120 minus 2, that is 118. Okay, in the same way the number of divisors. Okay, then go to the next question. Question number 4. The sum of divisors of 2 power 4 into 3 cube into 5 square is dash. Nana, all are doing or not? Give the response, Nana. Are you getting or not? Give the response. Deepti, Shruti, Nishan. Sum of divisors. Formula just now we written P1 to the power of, okay, alpha 1 plus 1 minus 1 by P1 minus 1 into, next P2 to the power of alpha 1 plus alpha 2 plus 1 minus 1 by P2 minus 1. Next P3 to the power of alpha 3 plus 1 minus 1 by P3 minus 1. Number of terms are 3 are there. Let us complete that 3 terms. So the value is goes to how many power? This is alpha 1, this is alpha 1, this is alpha 2, this is alpha 3. Now P1 means denominator P1, P2, P3. Then 2 power 5 minus 1 by 2 minus 1. And then P2 nothing but 3 power 4 minus 1 by 3 minus 1. And then next one is 5 power 3 minus 1 by 5 minus 1. So that is goes to 32 minus 130, 31 into 3 power 4 means 81. 81 minus 1 nothing but 80 by 2 into 5 cube means 125. 125 minus 1 is 124 by 4. So that is 31 into 40 into how much, Nana? 31. Then you can multiply, then the answer we will get. Options are given. Okay, 31 into 31 into 4. 31 into 220 into 4. That is 38,440. That's all. This is the answer. The sum of the divisors. Okay. In the same way, next question is given. Question number 5. Sum of even divisors. Sum of even divisors of 2 cube into 3 square into 5 square is dash. The formula is what? P1 into P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1. Next P2 to the power of alpha 1 plus 1 by P2 minus 1. Next P3 to the power of alpha plus 1 minus 1 by P3 minus 1. Then the values goes to P1 is nothing but 2, and then 2 cube minus 1 divided by 2 minus 1, and then this value is P, so that is 3 minus P cube, 3 cube minus 1 by 3 minus 1, and then 5 cube minus 1 by 5 minus 1. So that is total 8 minus 1, 7, 2 into 7 into 27 minus 1, 26 by 2 into 5, 125 minus 1, 124 by 4. So 14 into 13, 2 1 ja, 2 3 ja. 14 into 2 6 ja, 2 4 ja. The answer is goes to 60451. That's all. This is the type of questions are given. Okay, this is the concept of divisors. Then go to the next concept. Shall I move? Give the response, Nana. Are you getting or not? Give the response. All are objective concepts only. Some people are not listening the classes. What happened? We'll do the next concept. Shall I move? Shruti? Sindura, Pranav, Nishita, Rohit, all are objective concepts only. Okay, next concept, exponent of n factorial. Exponent of n factorial. What is the formula? First you learn exponent of n factorial. So if n is a natural number and in n factorial the exponent of a prime number be p such that step of n by p plus step of n by p square step of n by p cube. So this is said to be exponent of n factorial. So write down the formula. Afterwards I will explain some basic problems, then you can get the clarity. So n is a natural number. N is a natural number. Okay. In n factorial, the exponent of a prime number b, let it be some p. Okay. This can be defined by formula is step of n by p plus step of n by p square plus step of n by p cube plus so on. So the formula is exponent of n factorial, that is to write as step formula, or else next another form, shortcut form is we can write step of n by p. What is the exponent of? Nothing but factorial values they will give, and the next note you can write here, n is a positive integer and then p also prime number, then the largest integer k, let it be k, such that p power k divides n factorial is called exponent of the prime in n factorial. So let us take one example, then after it we can get the answers. Okay, what is the next one? First basic one you can take. What is the term? Suppose express 5 factorial as a product of prime number. The question is that step nothing but integral part you can take. So what? General thing nana 3 factorial is there. Suppose we can write 2 into 3. So that is 2 power 1, 3 power 1. Next 4 factorial is there. Then we can 24 we can write. 24 can be written as 2 square 2 cube into 3 power 1. Okay. So let it be as a prime factorization. 2 and 3 are just now divisors we have learned. 2 cube into 3 power 1. Whereas 5 factorial is there 120. Then we can write 2 cube into 3 power 1 into 5 power 1. 8 into 3, 24. 24 5 is 120. Similarly, the problems in the form of largest numbers are there. Suppose 100 factorial is there. How many prime factors? Then we can write as 1 into 2 into 3 into 4 into 5 into so on up to the factorial means 100. How many times the divisors of 2 power alpha 1, 3 power alpha 2, 5 power alpha 3 we can write, something goes on. So how many exponential we can write? That is the formula. By using the formula, step of n by p, step of n by p square, step of n by p cube, so on, like that we can do. So let us take, we have 2 power 5 factorial is given in the question. 2 cube into 3 power 1 into 5 power 1 is there. So 5 factorial is nothing but, first you write as a prime factors, 5 prime factorization, exponential of 2. Exponential of 2 nothing but formula is n by p. Formula is what? Step of, what is the formula? First write down. N by p formula is step of n by p square plus step of n by p cube, so on up to. Here 2 is there, then the number is 5, then 5 by step of 2 and step of 5 by 2 square and step of 5 by 2 cube and then step of 5 by 2 power 4, like this we will do. So step of 5 by 2 nothing but whatever the value you can get, 2.5, and then 5 by 4 nothing but 1.25, and next 5 by 2 cube we cannot get, so then only 2 factors is enough. Step nothing but step of 2.5 we can write as some integral part plus fractional part, that is 2 plus 0.5. Then the value always you take integral part value only you can take. This is 2, and 1.25 can be written as step of 1.25, then it is 1 plus 0.25. Only integral part you can take, that is 2, that is 1, 3. So therefore the value power is here 2 cube. Okay, it is verified. If it is no some value is there, we can verify. If it is bigger number is there, we cannot. So that is why this formula can be used as step of 5 by 3z. P1 is 2 and P3 is 3 and 5, so on. So let us take the value step of P 5 by 3, step of 5 by 3 square, and then so on. This is enough. Step of 5 by 3 means how much? 1.7. And then 5 by 9 nothing but 0 point something. So 0 0.5 by 9, 5 9 ja, 9 5 8 ja, 0.8 something. Okay, then you write as only integral value. Step of 1.7 can be write 1 plus 0.7. That's only for 1. So it is obviously 0. So the value is 1. Okay, it's verified, 3 power 1. And similarly, step of 5, exponent of 5 in the 5 factorial, that is step of 5 nothing but 5 by 5 and step of 5 by 5 square, it's more than value, it doesn't take. This is not necessary, just this is 1, only 1. Therefore 5 factorial can be written as 2 power alpha 1 into 3 power alpha 2 into 5 power alpha 3, then it is goes to 2 cube into 3 power 1 into 5 power 1. So then it is write as 1 into 2 into 3 into 4 into 5 is there. Then we can represent as this form. This said to be exponent of n factorial concept. Okay. Let us try the second example, then you get an idea. Find the number of divisors of 10 factorial. 10 factorial. So let us take the first value, exponent of 2. Begin with exponent of 2. Step of 10 by 2. Then step of 10 by 2 square. Plus step of 10 by 2 cube. Step of 2 power 4, 16, more than the value. So doesn't take. So that is 5 plus 2, 10 by 4, 2 point something. Then 2 only, 10 by 8, 1 point something. Let us take only 1. So the total value is 8. In similarly, exponent of this value, exponent of value, let us take the prime numbers, that is 3. Then 2, 3, 5, let us take. Step of 10 by 3 and step of 10 by 3 square. Don't take the more than number. So 10 by 3 nothing but 3 point something, step means 3 you can take. 10 by 9 something, 1 point something, that is 4. 3 plus 1, 4. And then go to the exponential prime factoration by 5. The prime factorations only you can take. How many factors will come? So that is 10 by 5 step plus step of 10 by 5 square and then step of more than value. So you can should not take. This is also not necessary. This is only 2. Okay. And therefore 2 power alpha 1 into 3 power alpha 2 into 5 power alpha 3. If it is 7 power also you can take 7 by step of 7 by 10 also you can get. Okay, let us try. 7 also lesser below the 10. Okay, exponential of 7, exponent of 7, 10 by 7 and 10 by not necessary, that is only for 1, that is the value only 1, so it gives you equal to 1. Therefore number of divisors 2 power alpha 1, 3 power alpha 2, 3, 5 power alpha 3 and 7 power alpha 4, more than enough. So 2 power alpha 1 nothing but how many factors? 8. 3 power means how many? 4. And then 5 power alpha 3 nothing but 2, and 7 to the power of all the 7 power 1. But in the question number of divisors just now we have completed. Number of divisors nothing but alpha 1 plus 1, alpha 2 plus 1 and alpha 3 plus 1 and then alpha 4 plus 1. Then the total value becomes to 9, 5, 3, 2, that is goes to 270. Therefore the number of divisors of this expression is 270. Like this questions in the expansion day, the examination point of view, this is the most important concepts. Okay, tomorrow I'll explain the remaining topics, Nana. Revise all those. Whatever you have the doubts, ask me in the, please make a call to me. Okay, thank you, Nana. Right, tomorrow I'll explain remaining problems.